In this module, we will discuss about the mean of grouped data. The mean or average of observations, as we know, is the sum of the values of all the observations divided by the total number of observations. That is, if x1, x2, x3, x4, x5 till xn are observations with respective frequencies f1, f2, f3, f4, f5 till fn, then this means observation x1 occurs f1 times, x2 occurs f2 times, and so on. Now, the sum of the values of all the observations is equal to f1 x1 plus f2 x2 plus so on till plus fn xn, and the number of observations is equal to f1 plus f2 plus so on till plus fn. So, the mean of the data is given by x bar is equal to sum of f1 x1 plus f2 x2 plus so on till plus fn xn upon sum of f1 plus f2 plus so on till plus fn. This can be represented as sigma fi xi upon sigma fi. Let us apply this formula to find the mean in this example. Example: the marks obtained by 30 students of class 10 of a certain school in a mathematics paper consisting of 100 marks are presented in a table below. Find the mean of the marks obtained by the students. To find the mean marks, we require the product of each xi with the corresponding frequency fi. So, let us put the values in a column like this. Now, x bar is equal to sigma fi xi upon sigma fi is equal to 1779 upon 30 is equal to 59.3. Let us see an important point to be kept in mind while converting the ungrouped data into grouped data by forming class intervals of width, say 15. While allocating frequencies to each class interval, students falling in any upper class limit would be considered in the next class, that is, example, 4 students who have obtained 40 marks would be considered in the class interval 40 to 55 and not in 25 to 40. Now we have this table. Now, for each class interval, we require a point which would serve as the representative of the whole class. It is assumed that the frequency of each class interval is centered around its midpoint, also called as class mark. We find the midpoint of a class or its class mark by finding the average of its upper and lower limits, that is, class marks is equal to sum of upper class limit and lower class limit upon 2. For the class 10 to 25, the class mark is 10 plus 25 upon 2, that is 17.5. Similarly, we find the class marks of the remaining class intervals. And we have this table. The sum of the values in the last column give us sigma Fi xi. So the mean x of the given data is given by x bar is equal to sigma Fi xi upon sigma Fi. This implies 1860.0 upon 30 equals to 62. This new method of finding the mean is known as the direct method. Sometimes, when the numerical values of xi and fi are large, finding the product of xi and fi becomes tedious and time-consuming. So for such situations, we use another method of reducing these calculations. Let us try this method. The first step is to choose one among the xi's as the assumed mean and denote it by A. Also, to further reduce our calculation work, we may take A to be that xi which lies in the center of x1, x2 and so on till xn. So, we choose A is equal to 47.5 or A is equal to 62.5. Let us choose A is equal to 47.5. The next step is to find the difference di between A and each of the xi's, that is, the deviation of A from each of the xi's. That is, di is equal to xi minus A is equal to xi minus 47.5. The third step is to find the product of di's with the corresponding fi's and take the sum of all the fi di's. The mean x bar here will be sum of A and sigma fi di upon sigma fi. Substituting the values of A, sigma fi di and sigma fi, we get x bar is equal to 47.5 plus 435 upon 30 is equal to 47.5 plus 14.5 is equal to 62. Therefore, the mean of the marks obtained by the students is 62. The method discussed above is called the assumed mean method. Do you observe that in this table, the values in column 4 are all multiples of 15? So, if we divide the values in the entire column by 15, we would get smaller numbers to multiply with fi. So let us have a new column ui for this. The new table is like this. Now, the mean x bar is A plus h into sigma fi ui upon sigma fi. Now, substituting the values of A, h, sigma fi ui and sigma fi, we get x bar is equal to 47.5 plus 15 into 29 by 30 equals to 47.5 plus 14.5 is equal to 62. So, the mean marks obtained by a student are 62. The method discussed above is called the step deviation method. We can use any of these methods as per our convenience.